All right, welcome back to the deep dive. Today we're diving into a security vulnerability. It might sound a little bit like, deep internet stuff, but it actually has some really surprising consequences for, well, pretty much everyone. And it's called DNS rebinding. So, you know how websites work, right? You type in a name like google.com and you get a page.
Yeah.
But what happens when that connection, that seemingly simple connection is manipulated? Like, what if it lets a malicious website get into places on your network that it really shouldn't be able to access?
Mm.
That's really the heart of DNS rebinding. It's a pretty clever trick that allows attackers to bypass the same origin policy. It's like, a fundamental security rule on the web that's supposed to keep websites in their own little sandboxes, so to speak.
Yeah, I mean, you can think of the same origin policy kind of like a digital equivalent of your home address. It makes sure that one website can't just, wander to the territory of another website and start accessing your private information or messing with the other online services you might be using.
Yeah.
But DNS rebinding, it kind of finds this sneaky loophole in how your browser figures out those territories, those boundaries.
Okay, so how does this digital border crossing actually work? I mean, let's say I stumble upon a website with some bad intentions.
Right.
What happens then?
So initially, the web address you click on, let's just call it, sneaky.com for now.
Okay.
That address will point your browser to the attackers, to their own computer, their server.
Okay.
And this is what allows them to send some potentially harmful code to your browser. Usually it's JavaScript.
Okay.
But, at this point, it's not really anything too out of the ordinary for, just a shady website.
Yeah.
That's just the initial setup. The real magic, the rebinding part, that happens when the attacker starts manipulating the domain name system, or DNS, for that sneaky.com address. And they do this by setting a really, really short TTL.
TTL.
Yeah, that stands for time to live.
Okay.
For the initial IP address that your computer gets.
So it's like a temporary lease on that IP address or something like that.
Yeah, exactly.
Yeah.
It basically tells your computer how long it should remember the IP address for sneaky.com before it needs to go ask the DNS server again, hey, what's the address?
Okay.
And normally, this might be hours, but in this case, with a very short TTL, your computer forgets the initial IP address almost immediately.
Okay, so this is where it gets really interesting, right? So the malicious code from sneaky.com, it's now running in my browser.
Right.
And it tries to make another connection back to sneaky.com.
Yeah.
But because the TTL has expired, my browser now has to go look up the IP address again.
Exactly. And this is where the attackers, their control over the DNS really comes back into play. So this time, when your browser asks for the IP address for sneaky.com, the attacker's DNS server, it responds with a totally different IP address. And this is the crucial part. It's often an internal IP address, within your home network or your work network.
So my browser, it's still under the impression that it's talking to sneaky.com.
Right.
It just happily sends its request to this new internal IP address.
Yep. It's almost like the website has, kind of pulled a fast one, changing its destination mid-communication.
Yeah, like a beat and switch.
Yeah, that's a great way to visualize it. Because the browser thinks, in its little digital brain, it thinks it's still within the original website's origin, like its territory.
Mm-hmm.
So it completely bypasses the same origin policy, which would normally prevent, a website from just freely talking to other devices on your local network.
Mm-hmm.
And this redirection, it can sometimes even slip past those basic network firewalls.
Oh, wow.
Because the initial connection, remember, it was to an external site, to something that seemed legitimate.
Right. So this sounds like a loophole that, someone could exploit for quite a while. I mean, when did this DNS rebinding issue first come to light?
So it's actually not a new trick. DNS rebinding, it was first identified way back in 2007.
Wow, 2007.
Yeah. And what's really remarkable and a bit unsettling is that, despite being known for over a decade, it's still a relevant security issue. This isn't just some obscure, theoretical weakness in the internet. It's something that attackers are actively using.
Right. Okay, so why should you, the listener, care about this? I mean, this might sound like a pretty technical vulnerability.
Yeah.
But even if you don't spend your days, messing around with network settings, this could have some very real implications for you. We're talking about scenarios where Just visiting a compromised website could allow attackers to like snoop around your home network,
Yeah.
maybe mess with your smart devices, or even gain access to like internal systems if you're on a corporate network. We've got some real world examples coming up that I think will really drive this point home. But first, I think it's helpful to really understand how DNS works.
Yeah, absolutely.
Because, it's this sort of unsung hero of the internet.
Wow.
We use it all the time, constantly. But most of us don't really think about, what's going on behind the scenes. So when I type in, like, example.com into my browser, what's DNS actually doing?
So you can think of DNS, the domain name system, as this global directory service. It's kind of like a giant phone book for the internet.
Oh, okay.
So when you enter a domain name,
Yeah.
something like example.com, which is human readable, your computer needs to find the actual IP address of the server that's hosting that website. And that IP address, it's a numerical label. It's, something like 192.0.2.1. So
Yeah.
DNS is what translates those easy to remember names into those numerical IP addresses that computers use to actually talk to each other.
Okay. So my computer sends out a request, like a DNS query, to a DNS server.
Yeah.
And that server looks up the IP address for the website I want to visit.
Exactly. So when you type in that web address, your computer, or often your router on behalf of your computer,
Okay.
it sends a query to a DNS server, which is usually provided by your internet service provider.
Right.
But you can also choose to use different DNS servers.
Right.
And that DNS server, it looks in its records, it finds the IP address associated with the domain name that you requested, and then sends that IP address back to your computer.
Okay.
And then your browser, it uses that IP address to actually establish a direct connection with the web server that's hosting the website.
Makes sense. So where does this rebinding thing, this maneuver, where does that fit into this whole, seemingly straightforward process?
So the manipulation really hinges on that TTL value we talked about earlier, the time to live.
Right, right.
When a DNS server provides an IP address,
Mm.
in the response to your computer's query,
Mm.
it also includes this TPL value.
Okay.
And that TTL, it tells your computer, or more accurately, your local DNS resolver, which is usually built into your operating system or your router.
Okay.
It tells it how long it should store or cache that IP address before it needs to go back to the DNS server and ask for it again.
Heard it.
And a typical TTL might be, several hours,
Okay.
meaning your computer remembers that IP address for quite a while.
So it doesn't have to keep bothering the DNS server every time I go back to the same website.
Exactly. It really reduces the workload on DNS servers,
Makes sense.
and it speeds up your browsing experience.
Huh.
However, for a DNS rebinding attack to work, the attacker needs to force your browser to make another DNS request for the same malicious domain.
Mm-hmm.
And they need to do this pretty quickly after it's already received that initial attacker-controlled content.
Right, right.
So that's why they set that initial TTL to be extremely short. We're talking just a few seconds or sometimes even 0.
Wow.
This makes sure that your browser will very soon forget that initial IP address, which was, remember, the attacker's server.
Oh, so the short TTL is like the key to making the browser ask for the address again quickly.
Exactly.
Okay, so what happens once the browser forgets the first IP?
So once the TTL expires and the malicious JavaScript or whatever code is running in your browser, when that tries to contact the original domain again, your browser has to do another DNS lookup.
Okay.
But this time, the attacker's DNS server, it responds with a different IP address.
Yeah.
And this second IP address, it's often a private IP address that's on your local network. So this might be something, like an address in the 192.168.x.x range,
Okay.
which are very common for home and office networks.
Right, right. And so my browser, it still thinks it's communicating with that original domain, sneaky.com.
Yeah.
So it just blindly sends its request to this new internal IP address.
Yep. It's like the website got a new set of keys.
Uh-huh.
And these keys, they can unlock doors on your local network that it shouldn't have access to.
That is a great analogy. So yeah, the website's identity, it stays the same in the browser's eyes, even though its actual network location has changed.
Exactly.
And this is what allows it to bypass that same origin policy.
Right.
And potentially interact with all sorts of things on your local network, devices, services that normally an external website wouldn't be able to touch.
Yep. You can think of it as like you said before, like a classic bait and switch.
Yeah.
But it's happening at this really fundamental level of how web addresses are resolved.
Right, right. Okay, so this all sounds, it sounds pretty theoretical, even with the analogies. I mean, are there actual, like, real-world examples of DNS rebinding being used in attacks?
Oh, absolutely.
And what kind of damage can it actually cause?
So while the technical details, yeah, they might seem a bit abstract,
Yeah.
the consequences are very real. One common scenario is gaining access to internal web servers and applications.
Oh, okay.
So a lot of organizations, they have internal wikis, administration panels for network devices, databases, all sorts of tools that are intentionally only accessible from within their local network for security reasons.
Right.
DNS rebinding can give an attacker a way to reach these systems, potentially through a compromised employee's browser.
So, like, an employee clicks on a malicious link and suddenly an attacker has a way to, like, probe their company's internal network.
Yeah, exactly. It's a big security headache for businesses.
Right.
And the risk isn't just limited to corporate networks.
Oh, okay.
DNS rebinding can also be used to target vulnerabilities in local network devices that we all use, like routers, IoT devices, smart cameras, thermostats, even printers.
Oh, wow.
A lot of these devices have web-based interfaces for configuration.
Okay.
And these interfaces, they often have weak security, maybe no authentication at all.
Right.
Because they're designed with this assumption that they can only be reached from within that trusted local network.
Right.
But a DNS rebinding attack, it can allow a malicious website to start interacting with these interfaces without any proper authorization.
You mentioned IoT devices, which, I think is relevant to a lot of our listeners. I mean, could my smart speaker or my connected refrigerator be at risk from something like this?
Unfortunately, yes. There have been documented instances, even public demonstrations,
Yeah.
showing how these types of devices can be targeted.
Wow.
So imagine a scenario, right, where you visit a malicious website, you don't even know it's malicious, and it delivers some JavaScript code to your browser.
Okay.
After a DNS rebind, that code could start sending commands to your home automation hub or directly to individual devices on your network.
Oh, wow.
And depending on the vulnerabilities, this could lead to things like unlocking smart locks, accessing live feeds from security cameras, or even just gathering personal data that's stored on these devices.
Yeah, especially if they're not, properly secured.
Exactly, especially if those local APIs, those interfaces that the devices use to communicate, if they don't have strong authentication.
Right. Right. That is a really unsettling thought. I mean, just visiting a website could potentially compromise, like, the physical security of my home
Yeah,
or expose my private life.
that's exactly the potential impact. And it really underscores why this vulnerability is so significant. And beyond gaining, direct access to these systems and devices, DNS rebinding can also be a way to bypass other security mechanisms.
Okay.
For example, it could be used to circumvent SSRF protections.
SSRF, we talked about this briefly before. Could you remind us what that is?
Sure. So SSRF stands for Server-Side Request Forgery.
Okay.
It's a type of vulnerability in web applications where an attacker can trick the server itself into sending requests to arbitrary URLs.
Okay.
And this can sometimes be used to access internal resources that aren't directly exposed to the internet. Protections against SSRF, they often involve checks to see if the requested URL points to localhost, the server itself,
Right.
or to a private IP address.
Okay.
And DNS rebinding can be used to sneakily bypass these checks.
Oh, okay.
So the initial request from the server, it goes to an external domain, one that the attacker controls.
Okay.
But then, through the DNS rebinding trick, subsequent requests, the ones initiated by the server because it still thinks it's talking to that original domain, those get redirected to the internal target.
So the server thinks it's making a legitimate external request.
Yeah.
But it's actually being tricked into accessing internal resources.
Exactly. It's a very clever way to get around those server-side protections. And this isn't just theoretical.
Oh, okay.
There was an example where researchers showed how a file-sharing platform could be compromised
Wow.
using DNS rebinding to bypass SSRF protections.
Okay.
So this platform, it allowed users to upload files through a URL. And there were some measures in place to try to prevent the server from accessing localhost.
Okay.
But the researchers, they used a DNS rebinding tool to create a host name that would randomly resolve to either their own external server
Okay.
or to localhost with a very short TTL.
Okay.
And by repeatedly trying to upload files using this specially crafted URL,
Yeah.
they eventually tricked the server into making a request to localhost, which allowed them to potentially access sensitive files that were on the internal server.
So they were just playing the odds.
Yeah, they were basically playing the odds.
Eventually, it would hit localhost and they'd be in.
Exactly.
Wow. Okay, so DNS rebinding can also be used as part of what are called session fixation attacks.
Yeah, that's right.
Could you explain what that is?
So session fixation, that's where an attacker tries to force a specific session ID onto a user.
Okay.
So in the context of DNS rebinding, an attacker could use the rebinded connection to set a known session cookie for a legitimate website, in the victim's browser, while the browser still thinks it's interacting with that malicious domain.
Right.
And then if the victim later goes to that legitimate website and logs in, the attacker might already have a valid session ID.
Oh, wow.
Which could give them unauthorized access to the user's account.
That's pretty sneaky. Okay, so a victim's browser, if it's been compromised through DNS rebinding,
right,
it could potentially be used to make requests to other internet services.
Yeah.
Like, popular search engines, social media platforms, without those services even knowing that the requests are coming from a compromised machine.
Yeah, that's right. Because, because of the way DNS rebinding works, those services might not be able to properly identify the true origin of the requests.
Right, right.
Especially if they don't have really robust host header checks.
Okay.
And this could be used for all sorts of malicious purposes, like scraping data or even participating in DDoS attacks.
DDoS attacks.
Yeah, distributed denial of service attacks, where they flood a website with traffic to try to take it offline.
Wow. So my own computer could unknowingly be used as a weapon against other sites on the internet.
That's a real possibility.
Just because I happen to visit a bad website.
Yeah, it really highlights the broader implications of this vulnerability. And then finally, DNS rebinding can also be used to get around CORS restrictions.
Of course.
Yeah, cross-origin resource sharing. It's another browser security mechanism. It's supposed to control which websites are allowed to make requests to resources on a different domain.
Okay.
But by tricking the browser into thinking it's still within that original malicious domain's context, even after the IP address has changed.
Right.
DNS rebinding can sometimes bypass these CORS restrictions.
It's like a master key to the web.
In a way, yeah.
Okay, so given all these risks, are there actual tools and frameworks that attackers use to, automate these types of attacks?
Yeah, there are quite a few tools and frameworks that have been developed to make it easier to carry out DNS rebinding attacks.
Okay.
Some of these are for legitimate security testing.
Right.
But unfortunately, some are for, malicious purposes.
Of course.
Some of the well-known ones include, there's a comprehensive framework developed by a security research group. It's often referred to as Singularity.
Okay.
And then there's some simpler tools, like one just called DNS Rebinding.
Okay.
Another one called Rebind All.
Okay.
And a more extensive framework, it's known as the MWR DNS Rebinding Exploitation Framework.
Okay.
And these tools, they basically automate a lot of the process of setting up that malicious DNS server, the one that serves that initial payload,
Right.
and then orchestrates that IP address change at the right moment.
So it really lowers the bar for someone who wants to exploit this vulnerability.
Yeah, it does. There's one tool, it's called Red Tunnel, that's particularly interesting. It tries to automate a lot of the end-to-end exploitation process.
Okay.
So it can actually discover internal IP addresses within the victim's network.
Wow.
It scans those internal hosts for, open ports where vulnerable services might be running.
Okay.
It tries to bypass different browser limitations that can sometimes, mess up the rebinding process.
Right.
And it can even establish a network tunnel through the compromised browser right into the internal network.
Wow.
And that tunneling capability is pretty powerful. It could allow an attacker to then use other hacking tools.
Okay.
The ones that are used for exploiting databases or other systems.
Right.
They could use those against internal systems as if they were directly connected to the network.
So with a tool like Red Tunnel, an attacker could basically turn a web browser, like my web browser, into like a backdoor into the network.
Yeah, that's a good way to put it. It's a significant advancement in, how sophisticated these DNS rebinding exploits can be.
Wow. Okay, so considering that DNS rebinding has been known, for quite a while now, surely there's some defenses that have been developed, right?
Oh, yeah.
How effective are those defenses in practice?
So there are a variety of defense strategies that have been proposed and implemented.
Okay.
But the reality is there's no single, magic bullet solution.
Okay.
And a lot of common protections, they can be bypassed by attackers who are really determined.
Right.
So a good defense against DNS rebinding, it usually requires a layered approach.
Okay.
You have to address the vulnerability at multiple points.
Okay, so let's start on the server side.
Right.
Where the web applications and services are running.
Yep.
What kind of things can developers do to mitigate this risk?
So at the application level, one important measure is to enforce TLS, HTTPS,
Right.
on all internal services.
Okay.
So even if the attacker manages to redirect the browser to an internal IP address using DNS rebinding,
Right.
if that service requires HTTPS, that's secure connection.
Yeah.
The mismatch between the host name of the original malicious domain and the IP address of the internal service, it will usually trigger a certificate error in the browser.
So it'll be like, hey, this is suspicious.
Yeah, exactly. It'll say, hey, something's not right here. But it's important to remember that, users can be tricked into ignoring these warnings.
Right. Right. So HTTPS is good practice in general.
Yeah.
But it might not always stop a DNS rebinding attack if a user is, not paying attention.
Right.
Okay, what other server-side defenses are there?
So another really important one is strong authentication for all those internal applications.
Right.
So if internal services require, proper credentials, strong passwords, multi-factor authentication,
Right.
then even if an attacker manages to reach them through DNS rebinding, they still won't be able to get in without those valid credentials.
So like basic security hygiene is still important.
It's absolutely critical, yeah. Another important server-side defense is host header validation. So web servers, they often rely on the host header
What's up?
in incoming HTTP requests to figure out which website or application is being requested,
Right.
especially when you have multiple sites hosted on the same IP address.
Right. Right.
A good defense involves really carefully checking that the host header in every request matches the expected host name for that internal service.
Okay.
And in a DNS rebinding attack, the host header will often still contain the original malicious domain name.
Right.
So properly validating this header can effectively block the rebinded request. This is considered a primary defense strategy,
Okay.
but it needs to be widely adopted and it needs to be configured correctly across all the internal web services.
So if the internal server is like, hey, the host header says you're from sneaky.com,
Right.
but you're connecting to an internal IP address, something's fishy here.
Yeah, exactly. It can basically say, no, I'm not going to talk to you.
Okay. Okay. And what about just configuring internal services to only listen on localhost?
So that can offer some limited protection, but like we saw earlier with, with that example of bypassing SSRF protections, DNS rebinding can sometimes still get around that.
Okay, so server-side mitigations are good.
Yeah.
But they're not perfect on their own.
Right.
What about at the network level?
Right.
Are there things that, network admins can do to prevent this?
Yeah, absolutely. So network level controls can add another layer of security.
Okay.
One technique is called DNS masquerading,
Okay.
which can sometimes detect patterns in DNS queries and responses that are kind of characteristic of DNS rebinding attempts.
Okay.
Another really important thing is having strict firewall rules
Okay.
to limit access to internal resources based on the originating IP address.
Right. So like where the request is coming from.
Yeah, exactly. Or the network segment that it's coming from. This is just basic security best practice. But it can really help mitigate the impact of a successful rebind. So if an internal service truly only needs to be accessed from within a specific subnet, specific part of the network,
Right.
the firewall rules should be set up to enforce that.
Makes sense.
Another approach is to configure network devices to actually block DNS responses that come from external servers that contain private IP addresses.
Okay.
So the idea is to prevent the attacker's DNS server from ever returning internal IP address to a client within the network.
Right. Right.
But as we've discussed, there are techniques that attackers can use to get around this type of filtering.
Bypasses like using CNME records.
Exactly. So instead of the attacker's DNS server directly returning a private IP address,
Right.
it can return a CNME record
Okay.
that points to an internal host name.
Okay.
So for example, something like internal-server.local.
Okay.
And then the client's DNS resolver, the one on their computer or the
Yeah.
router. That will try to resolve this internal host name to its actual IP address using the internal DNS infrastructure.
Oh, okay.
And if the internal DNS resolution isn't also strictly controlled,
Right.
which it usually isn't because
Right.
it's needed for the network to function properly,
Right.
This basically bypasses that network-level filter.
It's like a redirect.
Yeah, it's a clever way to get around that direct blocking of private IPs.
So the initial DNS response looks fine,
Yeah,
but then it leads the client straight to the internal target.
exactly. And there are even more nuanced techniques,
Okay.
like using CNAME records for localhost itself,
Oh, wow.
which can sometimes evade filters that are, specifically looking for the 127.0.1 IP address.
You're right. It's like an arms race.
It really is. Attackers are always trying to find ways to get around these defenses.
So relying only on network-level filtering is probably not enough.
No, it's definitely not sufficient.
Okay, so what about on the client side?
Right.
The user's computer. Are there any things that browsers or users themselves can do to reduce this risk?
So there have been some discussions about potential browser-level changes
Okay.
that could offer better protection.
Okay.
So, for example, browsers could be designed to detect when the IP address for a domain changes from a public range to a private range during, a single browsing session.
Okay.
And that could be flagged as suspicious.
Right.
And the browser could potentially block further communication with that new IP address.
Okay.
But implementing this kind of feature across all browsers
Yeah.
and doing it in a way that doesn't break legitimate websites, it's a real technical challenge.
Right.
And older browsers, they would probably still be vulnerable.
Right, so it's not a perfect solution.
No.
Okay. Are there any other client-side mitigations?
So there are also browser extensions that give users more control over JavaScript,
Okay.
like NoScript, for example. And because JavaScript is usually the part of a malicious web page that makes those subsequent requests after a DNS rebind,
Right.
using extensions like this to block JavaScript from untrusted sites, it can offer some protection.
Okay.
But this can also break a lot of legitimate websites.
Right, because a lot of websites rely on JavaScript.
Exactly. So it's a trade-off between, security and convenience.
Right, right. Okay, so what about those built-in DNS rebinding protections that
Yeah.
are found in some open source DNS resolvers and public DNS services?
Yeah.